Okay, so we are now going to look at the kinetic theory of gases. So remember that we told you last time that a gaseous molecule generally undergoes a collision, and the collision is perfectly elastic, and when these molecules collide with one another and also with the walls of the container, they tend to maintain their velocity and kinetic energy. So let's say we have a gaseous molecules here. Of course, this is a container or a box containing a gaseous molecules, and this is y-axis, and this is x-axis, and this is z-axis. So assuming now we have a molecules like this, so this is the molecules, and these molecules have its own velocity as well as mass. So now if this molecules travels in this direction, so it will now strike these walls of the container. So as it travels this, remember that we have momentum is equal to mass times velocity. So therefore now if this, because it moves in s direction, we now have p is equal to mcx. So if these molecules collide with the walls of the container, it will bounce back. So velocity at the backward directions, that is momentum, is now equals to minus mcx. So now to get the change of momentum, we can now say the change of momentum is equal to mcx minus, open bracket, minus mcx. So we are now going to say minus times minus is plus, so we now end up of having 2 mcx. So remember, this is the change in momentum. So the rate of change of momentum is equal to 2 mcx, and whenever we said rate, it means divided by time. And remember, from our basic biology, from our basic physics, we have velocity is equal to distance all over time. So this L stands for distance and T stands for time. So we can now say C is equal to L times 1 all over T. We want to make 1 over T subject of the formula. So therefore now C all over L is equal to 1 all over T. So therefore wherever this equation here can also be rearranged as 2mcx times 1 all over T. So wherever we see 1 all over T in this equation, then we'll now replace it with C over L. So now we are now going to say our rate of change of momentum is now equals to 2mcx times 1 all over, times C all over L. So remember that we said our molecules is traveling in x direction, so this one is also going to be this. So therefore the rate of change of momentum is now equals to 2mcx times x is now 2mcx divided by L. So remember, the rate of change of momentum in Newton's law of motion, remember the second law of motion, the rate of change of momentum is directly proportional to the force applied. So therefore now the rate of change of momentum is directly proportional to force. So we can now say this one is something as force is equal to 2 mcx squared all over L. So therefore remember from physics that pressure is equal to force all over area. So we now cross multiply. So we now have F is equal to PA. So therefore we can now substitute F with PA. So we now have PA is equal to 2 mcx square all over L. And remember, the area of a square, because the box we use is a square, so the area of square is 6L square. So therefore we can now substitute this A with this. So therefore we now have pressure times 6L square all over 2mcx square all over L. And this is the same thing as P is equal to 2mcx square all over 6L cube. So 2 into 2 into 6 we have 3, and 2 into 2 we have 1. So we now end up having P is equal to mcx square all over 3L cube. And this one is the same thing as, remember that L cube is equal to volume. So therefore now we can now see that P is equal to mcx square all over 3V, which is the same thing as PV is equal to mc square all over 3. So we can now use n to say the number of molecules, assuming now the number of molecules. If we have more than